Be, and here, by the way, is the Calman. This is just an early mock-up of the UI, but you've got the 7 parameters here, the button to measure peak luminance, so that you can put that into here. Whenever you, because the result of putting in these 7 parameters will be a completely different set of tone curves. Whenever you upload that to the TV, Calman will generate a new set of tone curve targets, and this is just some examples here with 1,000, 2,000. And you import these into Calman, and then on the next page we have an example reading. So this is a tone curve for a 4,000 nit metadata, and so we have the roll-off here with a clipping point around the 4,000 nit point. And now the delta E's represent what you ask the TV to do, rather than represent what PQ is. You can always go back to PQ. I'll just do that to show what the standard method looks like.
And one thing I wanted to summarize that I believe I understood from what you said, because it'll look at metadata, it'll look at HDR10, it'll look at HLG or whatever, and if it doesn't see Maxell or whatever, it'll assume it's 4,000 nit and all of that. This, even though you didn't use the brands, this will work with HDR10, Dolby Vision, HLG.
So Dolby Vision is slightly separate from this. Dolby Vision works on the basis of a configuration file. The configuration file for Dolby Vision contains that peak luminance and color gamut.
It'll look at that.
And Dolby Vision will look at that,
That's great. And you'll be looking at that.
Yes.
Yeah, that's great.
So this is what would have happened in the past.
And HLG as well.
HLG as well, yes.
Maybe
Although
HLG
is relative, so you don't need to put the peak luminance back in, because it's like gamma.
It's an analog. It's an analog circuit.
So now we have delta E errors shown from the deviation from PQ, and if I had chosen a roll-off point that started lower down, which may look better, you'd end up with delta E errors across the board, but that would be unfair, because what you should be doing is checking what did you ask the TV to do, and now is it doing the right thing. So those are the 2 things that we're introducing here. I think they're mainly aimed at enthusiasts. Calibrators tend to have a test pattern generator anyway, but the barrier
enthusiasts can set contrast.
Yes, they
peak
can.
And minimum luminance.
Yes.
Beautifully and perfectly.
Yes.
That's the most important element to set. And a consumer can do it with his eye, with no equipment.
Yes.
Right, with your test patterns that are so brilliant in there. And you can do even 0.5%, 1%.
Yes,
so you could do it better than ever before professionally. At home, with no equipment.
And even if you wanted to buy the equipment,
that's a really big deal.
The original cost was about $3,000 for a meter, a pattern generator, and software.
And software, and the know-how.
And the know-how. But now you're at $600, and you may not have the know-how, but you've got tools to help you.
And just do it in the Technicolor mode, and you're in good shape.
Yes, that's right.
Very good. So what can you share with us? Is there a new, I know that you're not LG Display, but can you share with us if this is a new panel for 2020 or whatever the year is?
It's not a new panel, but there are a couple of new panel features that are made and enabled this year. So if I go into the picture settings here.
And later in the year, when this comes out in the spring, summer, it will still be the carryover panel.
Not exactly. There's a couple of new features.
Other than these features, it will still
In terms of peak luminance and color gamut, there isn't any significant change.
That's where I was going.
Having said that, over time, the panels seem to be getting brighter and brighter.
Very nice.
I think it's just because we're learning more how to, what little tweaks to the production line result in a brighter panel. Oh, okay, let's keep doing that then.
Well, we've certainly noticed it in the C8s.
Right.
And that series.
So the first thing is True Motion. And if you go to user, this is the motion interpolation. But in the user section, as of last year, you had a control for black frame insertion. This year, the black frame insertion has been given 3 different levels. So you've got low, medium, and high.
What is it changing? The intensity of the black itself? Or the speed of when it flashes?
I need to find out, because all the samples I have were C8. When I'm doing my development for the calibration, I had a C9 processing board with a C8 panel. So I haven't. This is my first time experiencing it.
It was a good question. It's a tough question you're going to get.
So medium and low. So it does make a difference to the peak luminance.
But it does, of course, as it should, and it will. But it's nice that we have low, medium, high.
Yes.
That's a big upgrade in itself.
Well, and also the high was the previous on.
Yeah.
And this really is perhaps a little bit too dark.
This is great.
And and perhaps too flickering. So I think
That's great. So it helps you both.
The high seems to affect the picture negatively. Looking at it, almost seems like a
You may not use it.
like a flutter.
Right.
Yeah, it's actually
But the low and the medium are much better.
Yeah.
But
so-
there may be
medium
some
looks good.
extreme cases where you want to use high,
Yeah,
and you'll
maybe.
sacrifice the luminance just for a little bit for some
and
scene that you want to see.
And I think it also depends on your viewing environment.
I'll bet law enforcement, when the cops play back the
Yeah.
video, they want to see every detail in every frame.
Well, what I've noticed, and I actually first noticed this with 3D, is if you see flicker, if the rest of the world is not flickering, then it's distracting.
Right.
And so when we're watching this here, there's a huge big white thing behind, and that's not flickering, and this is. If you're in a dark room and the only thing you can see is the screen and black around it, then you won't even notice the flicker. It's not distracting anymore. Yeah, that's why 3D with active shutter glasses works for very large screens, but it doesn't work very well for a small screen because you've made the rest of the world flicker that wasn't before.
Right. Okay.
Anyway, that's the first feature that's new. The second one is, let me just go back and turn this off. The second one is the ability to change the amount of white boost in HDR mode. This is also available in SDR. It's labeled as peak brightness. So the default in previous years was high in HDR and off in SDR. That's still the same default, but now we have a menu for it. We didn't ever have that before. So if I turn off this, the peak luminance drops, but the color accuracy increases slightly. Now it's a little known fact that the Alpha 9 actually has much better color accuracy than the Alpha 7 for OLED only, because it has some OLED specific functionality that improves the color volume at the low end and pushes the color volume distortion up. This eliminates the color volume distortion altogether at the expense of peak luminance.
Yeah. So that would also include the SM99, it has a Gen 9.
It has
but
a Gen
it would
9
not
that-
have the benefits.
No, because it's an LCD.
Right.
Yeah. But it also, because it's an LCD, it also doesn't have the color volume distortion problems that an OLED has.
That's right. Very good.
So
they have a larger color gamut coverage.
So again, typically we put it on high, but the reason we could never do this before is if you put it on off, your peak luminance drops, and you've got no way to update your tone curve to adjust. Now we can use Calman, and we can put that peak luminance, the lower peak luminance in, and you're still tracking PQ. So that's those are the two new functions that are panel specific, to answer your question.
Yeah, very good. And a while ago, we spoke about how when it goes through its very final step of going from digital to creating a light source, that there was some little pickup of...
Yeah, last year there was a change.
Can you say that again?
I don't... You mean just repeat it, or?
Well, yes, because I didn't record it last year,
Oh,
and
okay.
I thought it was like one of the more important things.
Yeah, it was.
Is it okay?
Yeah. So there's two important things. One is that the TCON that does the digital to analog conversion. It's a 10-bit input, 10-bit 2.2 gamma, just like everyone else, but 10-bit 2.2 gamma input. And many times we've been asked, why is it either not higher than 10-bit, or why is it not PQ instead of 2.2 gamma? And one of the reasons is that when you convert from digital to analog, there's 2 bit precisions you need to know. Not just the 10-bit in, you also need to know what is the bit precision of the output. And the native response of the material that's used in OLED is linear. And so you need to have a very high bit precision on the output side because it's linear. And that is most often the limiting factor. LCD is not perfectly linear, but it has a similar situation where it's that output side of the TCON that's really the bottleneck. And from 2017 to 2018, we increased the bit precision there, which would have resulted in improvements in dark shadow detail over the 2017.
Which we've seen improvements in below 5%.
Yes.
We thought it was some improvement
in image processing.
In image processing.
Yeah, but it's actually that was a panel improvement for 2018.
Yes, it is. So it's not exactly a hardware panel improvement, but it's a firmware within.
No, it is hardware. It is a hardware.
It's a chip as well.
That's right. The chip changed for the TCON.
That is fantastic. Thank you. And is that exclusive to LG OLED?
LG Display OLED, yes. WRGB OLED. Sadly, even though I work for LG Electronics, that's not exclusive to LG Electronics.
So the other
vendors
get that benefit as well because they're using the same TCON.
Yes.
Right, because that's supplied by LG Display along with the module.
That's right.
Yeah.
The other thing, which I believe is exclusive to LG Electronics, is we have a feature which we're not marketing because it's too complex, but I will tell it to you anyway, and that is a different way of sending the RGB data to the panel that gives us pixel level control over the white boost. And the way we're using that is there is some level of distortion that happens because we're increasing white to increase the peak luminance, and we're able to adjust where that distortion occurs. In the past, 2017 models, the Alpha 7 models, they used a global color saturation boost to compensate for a desaturation caused by adding white, but that desaturation wasn't global, so using color boost is not really the right way to do it. And it's kind of somewhat not obvious, because even if you look at competitor products, everyone has a color slider, and in the UI it will still look like there's no color boost. But if you were to get down to the chip level, you'd see actually there is, because if there wasn't, you'd see massive desaturation.
And that's on the processing chip.
Yeah, and that's done
driven with firmware as well,
yes,
the software.
And that global saturation boost is done by, as far as I know, all manufacturers to compensate for the desaturation.
For desaturation of the white OLED.
Right. Whereas on
because you get a great color gamut on an OLED.
Yeah.
Yeah, on a WRGB OLED. I know.
Whereas with the Alpha 9 chips, we are able to shift that desaturation into the highlight region only, so that below around 300 nits there is no desaturation. And if you look in Calman, you'll see that. It's a little bit difficult to see because all of the other manufacturers, including LG with our previous models, we would have optimized that global saturation gain so that the color checker and the saturation sweeps all come out good. But if you start measuring other points in the color volume, you'll see that there is this distortion that is there, and it's massively improved with the Alpha 9, both last year and for the Gen 2. And I want to talk about that because I think that's a great benefit that we have over our competitors.
Thank you. I'm going to reach over and shake hands. You are the best. Thank you. How did you get an education like this? This would be my last question. You're an amazing presenter, and you're amazing with your skill and brains on this. You're awesome.
I don't have a degree. I don't have an undergraduate degree. So everything I know is self-taught over the last 4 or 5 years.
Absolutely amazing. You must have been some crazy kid with great parents.
Yeah, that's a good point. I should credit my parents, yes. I'd like to thank my parents, my wife.
Thank you again, Neil. Thank you.